Right, as you can see, solving equations by substitution is our next topic. And we've solved equations before, right? For example, if I had a plus 7 equals a negative 4, what would we do to both sides to solve this equation? Let's see, they're adding 7, so we'd subtract 7, right? And we get a is equal to a negative 11. That's pretty straightforward. When we have an equation with one letter, it's fairly easy to solve it. The problem is, though, when we get to something like this, if I had, say, x plus 2y equals a negative 10, and if I asked you to solve it for x and y, well, we need to know a little bit more information. And this is where this thing called solving equations by substitution comes into play, so that we can solve an equation for both variables. So let's take a look at example 1. It says use substitution to solve for x and y. Now, notice I have two equations here, and don't get confused with the bracket next to it. All it's showing is that we have two equations. And with these two equations, notice that in the top equation I have an x and a y, and the bottom equation I have an x and a y. And we're going to use substitution to do this. Now, if I told you, or if I showed you another equation, say that I have an equation of y equals 2. Now that's an equation, right? Because it has an equal sign. Well, what is y? If I had that equation, y equals 2, what's y equal to? And you'd say, well, duh, it's equal to 2. And that's right. Well, it's the same process when we use this substitution thing. Notice that in the second equation, x is equal to something. Now, x isn't just equal to 5 or equal to 2, like the one in the blue is. It's equal to 4y minus 10. But you know what? It's the same concept. So when I say, what's x equal to, you're going to say, it's equal to 4y minus 10. X is the same thing as 4y minus 10. This is what x is. It's 4y minus 10. So what we're going to do is we're going to take what x is in this equation, which is 4y minus 10, and we're simply going to place it into the other equation right there, because that's what is x again in the top equation. What's x equal to? Well, I know that from the bottom equation it's equal to 4y minus 10. And hence the term substitution. We're going to substitute 4y minus 10 into the other equation for x. So I'm going to write that. So we have 2. Now, here's where you got to be a little careful, though. I'm going to take 2 times whatever x is. Now, what's x again? 4y minus 10. What would be wrong if I wrote it like this? 2 times whatever x is, or in other words, 2 times 4y minus 10. Well, I'm only multiplying 2 by the 4y, and I'm leaving the 10 out. So what do I have to do here? And if you said that, you got to write it in parentheses. You're correct. So I have to take 2 parentheses, or 2 times whatever x is, 4y minus 10, plus the 3y equals 24. And all I did is in this top equation, all I did is I just placed what I knew x was from the other equation in for x in the top one. So I have 2 parentheses 4y minus 10 plus 3y equals 24. I just replaced x with 4y minus 10. I substituted. Now, what do you notice about this equation? How many variables do you have? You have 1, and we know we can solve an equation with 1 variable. All right, let's simplify the left side and distribute. So I have 8y minus 20 plus 3y equals 24. Continue simplifying the left side. 8y and 3y is 11y minus 20 equals 24. All right, solve it for y. Let's see, they're subtracting 20. So add 20 to both sides. They cancel. That's good. That's what we wanted. 11y is equal to 44. Now divide by 11. Y is 4. So now I know what y is. Y is equal to 4. Now how in the world am I going to figure out what x is? And let me erase part of this up here. How can I figure out what x is? So let's go back up to these two equations. Which equation would be really easy to place for and for y to figure out what x is? And the answer is this one right here. I know what y is, so I'm going to take, let's see, x is equal to 4 times whatever y is, which now I know what y is, it's 4, and subtract 10. So x is equal to 16 minus 10, so x is equal to 6. So I can write it now as x equals 6 and y equals 4. That would be a great way to write it. Or, as we've learned from previous lessons, whenever I'm using x and y in equations, usually has to do with graphing. And another way to write this is the ordered pair 6, 4, because the first number in an ordered pair is x, right? And the second number is y. So that would be another way you could write that. So what I did is I solved the two equations, or I solved the equations for x and y by using substitution. Let's do one more. Use substitutions to solve for x and y. Now let's take a look at the two equations. In one of these equations, I kind of know what one of the letters is equal to. And it's not the second one. It's the first one, right? In the first equation, I know what y is equal to. What is y the same as? Well, it's the same as x plus 7. So I know what y is. I'm going to place x plus 7 into the other equation for y. So I have x plus 2 times whatever y is. Well, I know what y is. It's x plus 7. And I use parentheses, equals my negative 16. Now I have an equation with one variable, and that's great because I know I can solve it. So I have x plus 2x plus 14 equals a negative 16. Continue simplifying, 3x plus 14 equals a negative 16. Let's see, we're adding 14, we'll subtract 14. They cancel, that's great. So I have 3x is equal to a negative 30. And finally, divide by 3, x equals a negative 10. Now I know what x is. So since I know what x is, I'm going to simply place that in right there. And by doing that, I'll be able to figure out what y is. So let's see, x is a negative 10 plus 7. So y is equal to a negative 3. So my answer then is x equals a negative 10 and y equals a negative 3, or a negative 10, negative 3. And that's what we have. Now, a kind of a side point here. Where do you think this ordered pair would lie? If I were to graph this equation on a coordinate plane, so we've done that, right? If you were to make an x and y table and graph that line, and then you made another x and y table and you graph that line, what do you think a common point would be on those two lines? And the answer is this. That would be a common point, or a common ordered pair on those two. Because if I stick a negative 10 in for x and a negative 3 in for y into either of these equations, it's going to make either of them true. So the topic here was solving for equations by substitution.